Welcome, class. This lesson is about functions. Okay. Now, functions in now is just like the functions we have in mathematics. Okay. So if I have a quadratic function, I'll have maybe f of x is equal to some ax squared plus bx plus c. That's a function. Now, such a function will have an input and it will have an output. So, given the x values, you will be able to find the functional values f of x, right? So, x is your input, f of x or y is your output, right? Okay. Now, similar thing happens. That you write a function, that function will take in input and then it gives an output. Okay. Now, there are two types of functions. There are inbuilt functions. So two types of functions. Two types of functions. So the first one, we say A is what? Inbuilt function. Inbuilt function. What are inbuilt functions? Example, you use a C. Okay, we have seen C. We have seen, for example, matrix, right? What else? With several of them, we have seen list. I'm not saying these functions are only data structures. It can be anything. I think we have also used, for example, even sum. Sum, for example, is also a function. So there are several of these. Why do we say inbuilt? They come, you have not built it. It's without Studio R. Okay. Now, what we are going to concentrate on will be the B part, which is user-defined function. User-defined functions. What are these functions? These are functions that a user writes on his or her own. Okay. Why are they important? They are important because certain times you want to do some peculiar things relating to your work or your thesis, and so when you can't find it in R, or maybe you want to use several functions together so that you get a unique output that is peculiar to you. Okay, so that you can collect several functions together, write your own function, and then you pulls all this together and then you get the required output. Okay, so R, just like any object, is an object-oriented programming, so it's made up of functions or objects and so forth. Okay. Now, so how are we going to do our user-defined functions? Well, there is a syntax that you can use, and I'm going to write this down. But remember, I did talk about functions in our last video on the quantitative plot. So an example of a function is here, but I'm going to give you the general form of a function, and we'll write it in such a form. Okay. So let's see. I have something over here, so I'll just call them, and then you can write. Okay. Now, so this is the syntax of a function. A function must have a name, and that is up to you to give the function a name, right? So I can say maybe kweku.fun, but your function name should relate to what it does, and that's what I said. Like if you are naming anything, whether it is a data set or a function, it should be related, or the name should reflect what that function does. So for example, if I want a function that will compute let's say simple linear regression, I may write it maybe simple regression, something like that, so that if I'm using it or somebody is using, the person will know that this function is about simple regression, something of that sort. Okay, so don't just name it for naming sake, but let it be interactive. Okay, so once you have the name, you then use your assignment statement. So in other words, you are assigning whatever is over here the name, function name. Okay. Then there is this keyword function. That is what will create the function. Okay. Remember I said a function takes in argument and it gives you what? An output. Oh, sorry, it takes in input. So input, the inputs in R, we call them arguments. Okay. So you call your function, you put your function, the arguments in parentheses. So look at this. You see the inbuilt function C, its name is called C, and it takes, arguments. And then if you run this, it appears on your console as a vector. That's it. That's what we mean by arguments. Okay. Now, once I have this, then I open brackets and end this bracket. And usually our studio will do so for you. Your task is now to write within this curly brackets. Okay. Now, what do you do in the curly brackets? You do all your expressions or statements, whatever you want to do, computations, what have you, is what we refer to as expressions. Okay. Then remember, your function must give you an output. So the output, you use another function called return to what? Get your output. Okay. So, but I must say that it is not every function that will return a value, right? It can return a graph, but for graph, you don't return it using the return function. You will just plot it, and it goes outside the function and plots. And we'll do an example just now that will show some of these things. And then the bracket ends. Yeah, you can return invisible, which means nothing will be returned. Okay, but if you want to return any other thing apart from a plot or a graph, then you use a return value. Okay, but we will see with an example. So let's see. Example of user-defined function. Okay. Okay. So here, I want a function to plot data set and compute the correlation. Sorry, let me go to the next line. And compute the correlation coefficient. So that's the example we want to do. We want a function. That function should take in two arguments, x and y, plot it, and then compute the correlation coefficient. Okay. So we are going to use the syntax or the structure of the function. So first of all, it needs a name. So what name should I give it to it? Well, one thing you should know is that you cannot use a name that is inbuilt in R. There will be conflict. So your naming should be different. Okay. Your naming should be different. Okay. Now, so let's see. So our function name, let's say we name a call plot. You see there is call plot and so forth. So you see what I did? Mine, the first letter is capital. The plot is also capital. So it will be different from what R knows. even if the spellings were the same. Okay. So that is my function name, call plot. So next I do what? The assignments. The next thing is what? Function. So I do function, and remember it has turned into blue, meaning the spelling is right. Okay. Now what are my arguments? I want correlation between two variables. So I'll name my variables x and y. So those are the arguments. Now then let me go inside. I now get my curly bracket. You see, I typed it and RStudio has closed it. So I'm now going to work within this. So the expressions. Okay. So first of all, I want a plot of it. Plot the data set. I will wait. So plot. First of all, I'll say plot. And then there's x and y. And then x lab is equal to x, maybe x, y lab. So I just label them. This one we have done plot, so everybody will be okay with it. Okay. What about main? Maybe I don't want to give it any title, so I'll say main is what? An empty set. Okay, next. So this should plot my x and y, right? Next is a correlation, compute correlation. Now the question is, how do I compute correlation in R? To do so, I need a function to compute the correlation. But when we finish, you will be in a position to now write your own function to what? To do or to be able to what? Compute correlation. Okay, so we want to find out how can we find correlation in R. Well, there is an inbuilt function called call. So let's look at the helper. So you see I've moved out of the function so that after call will come to it. So first of all, call, right? And there's call.test. We'll use call.test later on when we are doing hypothesis testing. But for now, we are only using call. Okay. So call is in the stats package. It computes correlation. So I come here and check call, right? And this function computes correlation between x and y, but I'm interested in the method. Remember in your 111, you did Pearson's product moment correlation coefficient. There's also Kendall's tau, and there's also Spearman's rank or Spearman's rule correlation coefficient. So we can use any of this. Okay. Now, so by default, you use a Pearson's product moment correlation coefficient. But if you want Kendall or Spearman, which are all related to rank, then you choose it as well. Okay. So we are going to use call. So if I want, I can just copy what I have highlighted here and then come and paste it here. Okay. But of course, I don't need all of them. So this use everything. I don't need it. I just want the default. And I must give my correlation a name. So maybe, what do I say? Maybe row. Oh, no, usually we use R. So this is the correlation. So let me say R. Okay. Now, so X, I'm going to say X is equal to X because that's what you should do. Like if my arguments were height and let's say weight, I would have assigned X as weight and so forth. So I'll just do that. And then Y is equal to Y. Now then the method, you are doing your work, so you know which method you are interested in. So if your data is on rank, you don't go and use Pearson, right? But you use either Kendall or Spearman. For now, we are going to use Pearson. So I'll delete everything with the exception of what? Spearman. Well, Pearson, yeah, like that. And please make sure that everything is correct. In other words, the parentheses, agree. You open it and close it, and so forth. So this is the Pearson's product moment correlation coefficient. Okay. Now, for plot, now what do I return? I will return only R, because my plot will just show at the plot side, so I don't need to return it. Okay. So let's look at this as our example. So I'll close this and run. Okay. When you finish your function, you must run for the name to take effect. Now, if you are finished running it, you must go to your environment and check. Okay, let me clean my environment because I have other data set there. So I'll run this again and see. There we go. So you see, once I run it, my function is now defined, right? And remember, I said your environment contains data sets and what? Functions when we started with the code. So you see, call plot is a function and it takes in what? Arguments X and Y. Okay. So now that I have call plot named in my environment, I am at liberty now to be able to use call plot to do my work. So now that we have our call plot showing here, I can now use it, right, to compute the correlation. Okay. So how do you use this function you have done? Okay. First of all, let's go to mass and make sure we have take mass, because we are going to use some data set in mass. Okay. So if I want to use this function, I'll call its name. Call plot. Because it's not uploaded when it's an inbuilt package, but you need to upload it. It's not one of the default ones where it will upload it. Yeah, because this is a class, but usually if you are doing this, you have your own data that you want to use it. So you read your data in there. But because I'm teaching you, I know that, okay, I need this data from mass or maybe from data set. That's why we use it. Okay, so let me look for mass and then I take it. Okay, so if I want to use it, I need the argument X. And X, I now want to find remember the anorexia data. I want to find the correlation coefficient between the pre-weight and post-weight. So I'll do anorexia post-weight. Okay. So that is all. I have X and Y. What is wrong? Okay, I have X and Y now, and then I'll be in a position to find my X and Y. Something seems to be wrong, but let's see. Okay, so there it is. So the correlation is 0.33 between them. If I go to plot, you see we have the plot there. And this one, if you look at it, well, as X increases, Y also increases, but it's mild, right? Because between 70 and 75, we are very large observations as compared to 90 to 95 as well. So the correlation is not that strong. Okay, so that's basically how you do your own function. But this is basic. As I said, there are so many things you can do to improve your function. Okay, so one of the things I'll talk about is if you give me this function and I run this and I'm getting 0.33, I wouldn't know what the 0.33 is. So I can go back to my function and put in a word to say, or a narrative to say that the correlation coefficient between this and that is this. You can do so. So that's what we want to do now. So I'll go back. Oh, yes. Yeah. So to do that, I can use the function called paste. Okay, paste. And for paste, I will write the correlation coefficient. The correlation coefficient is equal to, is equal to, and this will be displayed on the screen. Please, once you finish this, you see you have tempered with the function, and I will not store it automatically. So you must go back, even your R, you must go back and rerun the core plot function so that this new thing you have done will take effect. Now, I can even round this, right, to 2 decimal places, right, which means 2. You should round it to 2 decimal places. And I must close my parenthesis, and there it is. Okay. So once I do this, I must come back and highlight everything over here and rerun it. Once I rerun it, then all these things I did, paste, whatever, will take effect. And now if I repeat this, you see I get my plot, and also the correlation coefficient. Okay, so because this should be on a straight line, otherwise it's like you've moved it. But you've all seen it, so I can do it that way and go back and rerun it so that you have it on one line. Okay, so if I do this again, you see the correlation coefficient is my equal to is equate. Okay, let me go back and change it. Equal to. Okay, but whatever I do, I must rerun it for it to take effect in that particular function. So now it will be all right. So the correlation coefficient is equal to 0.33. So first of all, it has given me what? The write-up, as well as what? Rounded my value for me. Okay, so how can be interactive in some of these things. Okay. Okay, next we take a look at one more example for functions. Okay, and example 2. So here we need a function to compute the body mass index. You know body mass index. Usually you go to a hospital, they take your weight and height, and then they will tell you the body mass index. There you'll be able to see whether you are obese, you are a normal weight, or overweight, or underweight, and so forth. So body mass index. Okay. So such a function needs your weight and it needs your what? Your height. to get the BMI. Okay. Now, what I want us to do is that whenever we call this function, it should compute the BMI and then return a data frame. That data frame should consist of your height, your weight, and the corresponding BMI. So what do? We call it maybe BMI underscore fun. That's my function name. So I need a function, and then I need height. Please take note of the spelling for height and weight. Okay? Right? And then what is body mass index? It is weight over height. Weight should be in kilograms, height should be in meters. Okay? So weight over height squared. Okay. So here, I'll just put a comment, compute BMI. And how do I compute BMI? My BMI is assigned weight divided by height squared. Squared, I can use this. Where's the exponential? There. This. Okay. Alternatively, okay, so let me put a comment. We could have also done this as what? As BMI. Let me just copy this. That's an alternative way of doing it. BMI. Then I'll put this in brackets and say height times height, because I want height squared, right? So that's another way of doing this. You can do that. Okay. Okay. So something like that. Any one of them should work, but you shouldn't put the two together. That's why I've commented one out. Okay. So now, then maybe I need a table, and this table must be a data.frame. Okay. And I'll put in height, weight. Please, your weight should correspond to what you have there, otherwise you won't get it. And then BMI. Okay. Okay. Now, then I'm going to return and here I'm going to maybe round it. I want to round this table into what? 2 decimal places. So I want it to be 2 decimal places. So round tab 2, okay, so that we will have uniform. So that's my function. Let's see. So it's quite easy. I have the name of the function, the keyword function. It takes in height, it takes in weight. I compute my BMI, the formula weight divided by height squared. I compute, let me put in, create a data frame. Create a data frame. So I create a data frame that is made up of height, weight, and your BMI value. So once I'm done with this, I'll highlight everything. And there, I'll go and check. I also have my BMI as a function. It takes in height and weight. Okay. So now I'm going to do an example. So for that example, I'm going to call any height. So height, let's say the person's height is 1.85 and the weight is, let's say, 90 kilograms. What is the BMI? Let's run this. You see, you get what? Height, weight, BMI. Okay. So that's it. But we can also input in a vector, right? So let me say let's say height, age. I want to simulate some height. So I'll say maybe I sample observations from 1.5, let's say 1.45 to 2.1, let's say 2.2, 2 feet, 2 inches. And then how many? Size, maybe I want 10 people. So I'm sampling height of 10 from this. Oh, sorry, it can be. I have to use what? Sequence, right? I have to use sequence for this. So sequence from 1.45 to 2.2 by what? Maybe by 0.1, so to speak. Now 0.1, so size 10, but then I want replace to be true so that I can get the same people with the same height, right? I can select 2 people, but those people may have the same height. What about weight? So for weight, I can also use, let me say weight. I want to now, instead of sample, I'm going to simulate from what? A probability distribution. So remember the uniform distribution. You need starting point and then an end point. Okay. So I'll say I want to get some unif. You can look at the help files for uniform distribution. So it says n minimum maximum. So n is, what is your sample size? I want 10. What is the minimum weight? So minimum weight, I want, let's say 60. And then the maximum weight, I want the maximum weight to be, let's say 125. So what does this mean? It means simply that simulate from a uniform distribution. What is a uniform distribution? It's a rectangular distribution between the interval A and B. Each of them has an equal chance of being selected, right? It's a continuous thing. So that's what we mean. Okay. Now, so I run this and look at it. So the first person, of course, we are using different, this is random sampling, so we may not get the same thing. I look at it, my first selection was 1.45 and the person's weight is 107.8. The next person was 1.85, 107.5, and so forth. Okay, so let's see. So now I want to call my BMI function. And my BMI function, I'm going to find the weight and height of this. Okay, so height is assigned h, which is the vector h, and then weight is assigned w. So let's see what happens. There. So once I run this, I have weight, height, weight, and BMI. So the first person's weight was 1.45. Sorry, height was 1.45, weight 107, and the BMI is 51.28. The second person is 185, 107.48, 31.4, and so forth. Is that okay? So that's how a function should look like and how you can run your function to obtain results.